Our topic is Premium IOLs, and as Jack Holliday can only do, he covered so much of it in 15 minutes, so it enables me to kind of jump around a little bit. I want to acknowledge my financial disclosures. Jack showed this slide, and I want to amplify on that a little bit. He showed the growth of toric lenses to 14, so that the overall premium market is 14%, and he pointed out that that premium presbyopia-correcting IOLs has been flat for quite a while. And in fact, I think you could say it's been flat since almost 2008 because it's just gone barely up from 7%. And if you go back even further, it's only grown 1% from 2005 to 2012. So that's an astonishingly flat curve for something that doctors get paid a lot to do. And why is that so? I think there's a lot of reasons. The surgeons don't have confidence, I think, in the outcomes of multifocals. There's some concerns about quality of vision, and they're not prepared to deal with the patient complaints. There's the issue of the unpredictability of the accommodating IOL and how to work with that in their practices. I think surgeons lack confidence in their own surgical precision with biometry, as Jack alluded to, with the accuracy of relaxing incisions that are needed to get these lenses to perform at their best level. The need to do additional refractive surgical procedures. A lot of surgeons aren't doing excimer laser procedures, and nobody likes to do an IOL exchange, and unless you have a frame of mind and prepare yourself for it and are ready to do it on some of these cases who are really unhappy, that's another issue. And then there are no toric models available currently in the United States. And the growth of monovision, which has been aided by toric lenses. And I put this very high on the list of the reason that these others, the growth of the others has been flat. And I think that toric IOLs have actually cannibalized the premium IOL market because of the fact that that you can upcharge the patient with a high likelihood of success, and it's a lot less expensive to the patient. So I think that that's really what's happened in the premium market. I think they're going to expand somewhat as we get new approvals. We're going to get some new surgeons on board, but probably most of the high-volume surgeons are already using toric lenses, so I don't see a huge uptick in them. And in fact, Jack alluded to the fact that maybe relaxing incisions will cause a decrease. We're certainly going to see new models that will cover things like multifocals and accommodative. Relaxing incisions are not widely used. I think it's going to expand. It's the way people can pay for doing femtosecond technology cataract surgery, so I think that's going to grow. And I think that you're going to see probably some growth of multifocal IOLs with femto because you can do relaxing incisions, so you can better treat the astigmatism. But the disincentive is if you're going to charge an upcharge for the femto, then you have another upcharge for the multifocal or the premium IOL. There's going to be a bit of a tug and pull in that regard. Well, what about multifocal IOLs? How much better can they get? We have two categories, diffractive and refractive. We haven't talked about refractive in quite a long while. We all know about the diffractive designs that are available here and some additional ones internationally. There's a new refractive model that's sort of caught some interest in Europe, the Oculentis Lentis M+, which is a hydrophobic acrylic that has there's a 3 and a 1.5 diopter add model. It's kind of interesting because it has a clear zone and 1/2 that's for distance, and then the lower sort of 45% is for near, and the light in the transition zones is refracted away from the fovea. It's catching on to a certain extent. I've heard in Europe, I know one colleague really likes the 1.5 diopter model because it seems to do very little to impede distance vision, but it's good for the computer and cell phones. Well, what about accommodating IOLs? I think this is what we're all interested in. What's going to be required to get to where we want to be with them? And we all know that the mechanism of accommodation is from these slides from Adrian Glasser. Here's the ciliary muscle, here's the lens, and here is the resting ciliary muscle, and with accommodation, there's the ciliary muscle moving forward, and the lens becomes more spherical and moves forward slightly, as Jack had mentioned. So how do we harness this movement in the pseudophakic eye? Do we change the optic position? Do we change its curvature? Do we change its power? Do we do some combination of these? And where do we harness it? Do we put the lens in the bag? Do we put the lens in the sulcus? Or do we use other accommodative changes, such as pupillary constriction or convergence, as we might see with the Alenza lens? So we've got currently in the United States, of course, a single optic design, the crystal lens. The Tetraflex is still in trials. Does it move? We think probably not a lot. There may be some flexure. There's some uncertainty about the sort of the mechanism, and but certainly some surgeons are big believers in this, and other surgeons have used this lens and have stopped. Then we have the dual optic design, the Synchrony, which has not received yet FDA approval. It has two haptics, haptics connecting two optics with a 32 diopter optic that moves forward with accommodation, and has been demonstrated by ultrasound to move forward a certain amount. You know, what's going to be the future here? It does move, and it does maybe even change shape. We're not sure about that. That's, again, a capsular fixated lens. This is the ACO lens, which is a sulcus implanted lens in which optic elements slide over one another. I understand that there are clinical trials in progress. I have not gotten any data on that, and I'm hoping maybe our panelists may have heard something about it. And so the mechanism here is that the optic moves so that the optic changes power in that way. And then the new lens, which is in clinical trials, Enrique Barragan in Mexico, in conjunction with Steve Slade, has done a lot of work with this lens. And this lens has two elements that are both placed in the ciliary sulcus. And it works by a neuroadaptive technology whereby with the ciliary muscle relaxes, you actually get the accommodative effect. So it's rather counterintuitive, but the accommodation has been demonstrated, but it is a two-lens system, both of which sit in the ciliary sulcus. And so the optic moves, and thereby, by moving, it changes shape. And then there's the dynamic optic, the fluid vision design from Power Vision, which has, it's a silicone model that has silicone in these little reservoirs, and that has the same refractive index as the rest of the IOL, and as the ciliary muscle relaxes, the capsule contracts, the lens attains a greater spherical shape in order to achieve accommodation. And I know that they've done animal studies. I'm not aware yet of whether there are clinical trials on that. So here the optic expands and thereby changes shape. And then Jack has mentioned the Alenza lens, so I won't dwell on that. The optic changes power here independent of movement of the ciliary muscle and of the capsule. So I think it's not easy. This is a wide open field. In my view, there are lots of interrelated questions: how, where, what material. The hurdles for the capsular bag are, I think we're going to need to preserve certainly some measure of capsular flexibility. If you're going to place lenses in the sulcus, we have to fixate them in a safe way that's going to be long-term safe from a biocompatibility standpoint. And the electro-optical designs are going to have to be assured of safety and durability and quality of vision.